In this video, we're doing the angle at the center theorem, and this one can be really easy to get confused about because there's lots of different ways that it can look. But essentially what this theorem says is that when you've got a situation like this, then this angle is going to be 2 times the angle up there. So the way I would personally construct this circle is to get a situation like what this theorem gives us, is you pick any 2 points on the circle and you basically draw from those 2 points any other third point you want. And then you connect those 2 points up to the third point, but then really crucially, you also have the center of the circle and you connect these 2 points up to the center as well. So that's how you sort of construct a situation like this. And then once you have a situation like this, you know that, I don't know, if this angle is like 30 degrees or whatever, well, this one in here would be double that, 60 degrees. But you just have to be really careful about how you construct this because it's very easy to get wrong. There are a few other examples here and we'll cross that bridge as we get to it. So let's do a few example questions. Question 1, we have a very standard example. So you've got this angle here, 72, and then this has to be double that angle, so it'll be 144. You say angle ABC equals 2 times angle ADC by the, what's the name of this theorem? Angle at the center theorem. Great. Then what we have is, well, this angle, it's 2 times 72, which is 144, and that's another way of writing theta is angle ABC. So yeah, that question's done. Next one we have, this situation is pretty similar to the example that we have. It looks kind of like this number 3 here. So we're just going to make sure we got it the right way around. It appears that the angle there is going to be 2 times the little angle there. So theta equals angle ADC divided by 2 by, what's the theorem called again? Angle at the center. Therefore, theta equals, well, 118 divided by 2. What's that going to be? 59. Great. Cool. So if you want to see why this is true, remember I said you have to have the 2 points, which in this case would be like A and C. And I said you pick any third point. Let's call that B. And I'm going to draw a circle that's very similar to this circle, but just a tiny bit different. So A and B go up there, and then if the center was supposed to be here, you would then draw this bit in, and you would have this would be 2 theta, and then this bit would be theta. It's just that in the diagram, this red line has come down a bit, and it's become parallel to that blue line there. But it's the same idea, it's just the lines are squished together a bit. Okay, cool. So next one we have is pretty... Moving on, we're going to look at question 3 here. Now, before I start, there is actually an issue with this question. This circle here is impossible. I'd encourage you to pause the video and see if you can spot why this circle is impossible. Anyway, hopefully you've seen that the issue is this angle 74. And the reason that it's impossible is because this triangle here should be isosceles. BD is a radius and also DC is a radius. That means that these 2 angles should actually be the same. So I'm going to get rid of 74 and we'll just make that match 59 degrees. Now we can actually do the question. Okay, so first of all, we're going to look at this triangle on its own. So we're looking at triangle BDC. So what we're saying is that 59 plus 59 plus, I'm going to call this thing in here 2 theta, should equal 180. And this is because of sum of angles in triangle BDC. Now, I call this 2 theta because it's double that angle by angle in the center theorem. So we might just make a note of that. So angle BDC equals 2 times angle BAC. And this is because angle in center. All right, wonderful. Now I can just churn through the maths. So if we work through this, 59 and 59, let's see, that's going to be 118. subtract 2 theta, subtract 118 from both sides, so you get 2 theta is 62. Therefore, theta is 31 degrees, just like that. And that's the question done.